about differential equations. The variables y and theta satisfy the differential equation 1 plus y times 1 plus cos 2 theta dy d theta equals e to the 3y. When y is 0, theta is 1/4 pi. Find exact tangent theta when y is 1. So from the original equation, we can multiply both sides by something so that we can separate everything with y on the left side, everything with theta on the right side. So here, if we simplify, cancel out, we only have 1 plus y over e to the 3y dy, and on the right we cancel out. We have 1 over 1 plus cos 2 theta d theta, and we integrate both sides. Now we cannot integrate this directly, so we have to split the fraction 1 over e to the 3y and y over e to the 3y. And for the right hand side, we have to use this formula for cos 2 theta here. So we use this form, cos 2a equals 2 cos squared minus 1. We don't use this one or this one because the goal is to cancel out this one with minus 1, so we can have something without a constant and we can integrate. Okay, so now on the left, 1 over e to the 3y is e to the power of minus 3y. Split the integration here. And on the right, cancel out, so we have 1 over 2. 1 over cos is secant, so secant squared. We can integrate this real simple. Now for the y e to the minus 3y dy, this is not simple. We have to use integration by parts because we have a polynomial times an exponential. So when we have polynomial times exponential or logarithmic or trigonometric function, we have to use integration by parts. So the modified MF19 formula for integration by parts is integral u dv equals uv minus integral v du. We have to identify the u and the dv. If the u is y, the du dy is the derivative of y with respect to y, so we're gonna get 1. And hold on, and if you multiply both sides by dy, you get du equals dy. And for the dv, we have to integrate both sides. Just think of this as integral 1 dv is like integral 1 dx is x, integral 1 dv is v. So the integral here, using the MF19 formula, we get exactly the same thing, divided by minus 3 because of the minus 3 chain rule. So now we are ready to use integration by parts. The u is y, the v is e to the power of, or minus 1/3 e to the power of minus 3y, and the v again the same thing, and the du is dy. Okay, now simplify a little. Minus 1/3 y e to the minus 3y, minus plus, pull out the 1/3 out of the integration. We still need to integrate e to the power of minus 3y. Just like this, we get e to the power of minus 3y divided by minus 3. This is 1 over minus 9, and we're done with the integration. Now from here we integrate, we get again minus 1/3 e to the power of minus 3y. From here we integrate, we use integration by parts, we get this, so that's what we get. On the right, the integral of secant squared is tangent, and at the constant of integration just once on the right side. Here we can still simplify. We have this part and this part, minus 1/3 minus 1/9 is minus 4/9. And now this is the simplest form general solution, still with C. To find the particular solution, we need to plug in the boundary condition. When y is 0, theta is 1/4 pi. So we replace the y with 0 and the theta with 1/4 pi. So 0 times whatever is 0. E to the power of 0 is 1, so we have only minus 4/9, and tangent 1/4 pi is 1, so C is minus 4/9 minus 1/2 minus 17/18. Since we have the C, now we have the particular solution, so just rewrite this part, but the C is minus 17/18. Now question is to find the value of tangent theta. Find tangent when y is 1. So now we replace the y with 1. So this y is 1, this y is 1, this y is 1. Find tangent theta. So this is just minus 1/3 e to the power of minus 3, minus 4/9 e to the power of minus 3, and add 17/18 to both sides, and then we simplify minus 1/3 minus 4/9, that is minus 7/9, and then we multiply by 2, we get the final answer. Alright, that's it. I'll see you again next time.